Our last method is called the quadratic formula, and this guy always works. Basically, if we were to take the quadratic equation, ax squared plus bx, guys, I apologize. Some of them have equal signs instead of plus signs. Ax squared plus bx plus c equals 0. And if we were to complete the square, use all of those steps on this generic form, we would get the quadratic formula, which says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So notice that that is one huge fraction, everything over 2a. So the a, the b, and the c are the numerical coefficients of the three terms on the left. So be sure that these three terms on the left are in descending powers. Your squared term first, then your x term, then your constant. Also, be sure it's set equal to 0. So let's use the quadratic formula on this example, where 3 is our a, 2 is our b, negative 4 is our c. So x equals the opposite of 2 plus or minus the square root of our b squared, so 2 squared, minus 4 times our a, which is 3, times our c, which is a negative 4, all divided by 2 times our a, which is 3. So we get a negative 2 plus or minus the square root of 4 plus 48, I believe, divided by 6. So we get a negative 2 plus or minus the square root of 52 divided by 6. We want to see if that 52, that square root of 52 can be reduced. So we take 52, that's 2 times 26, which is 2 times 13. So again, we have a 2 squared, and the 13 does not have a pair, so he stays in. So we can rewrite this as negative 2 plus or minus 2 square root of 13 divided by 6. It's at this point that we can reduce, but everybody has to get divided by the same value. In other words, we have a 2 plus or minus a 2 over a 6. All three of those outside values can be divided by 2. So divide this guy by 2, divide this guy by 2, divide this guy by 2. We can't divide the square root of 13. It's a radical. So that's going to give us a negative 1 plus or minus. You can write that 1 in front of the square root of 13, but you don't have to, all over 3. So that would be our final answer.